Let me show you how can you run the CMap code, including preprocessing, training, testing, shape analysis, and the GUI data generation on your on your Google Colab. Um, I'm showing it with a free Google Colab account, so I only uploaded I only upload the two embryos and within 10 time point because for a free Google account there is limited memory and GPU computational resource. So let's start. And first, you should upload the CMap code I provide for you on your Google Drive first. Please make sure you already have a CMap code, name CMap code folder on your Google Drive root, and then you download this, uh, download the code from the link I give to you, and then you upload the code and the data set you want to process on the under your CMap code folder. This data folder experiment and models uses is the code, and the data set is the data you want to run. For example, here I have two embryos and I have 10 10 time point for this embryo. After you upload it on your Google folder, and then you should go to Google Colab. And open the Colab I give to you. Then you save the Colab to your Colab. After you done this, you should run the cell one by one. Here is the explanation of the Colab Jupyter notebook. And first step is that we need to group the 2D slide together into the 3D volume. The first step is that we should connect the free GPU provided by Google Colab first. You can see here it's connecting. It means Colab is giving your account the free GPU and some free system RAM, GPU RAM, and some free disk. And now you should link your Google Drive to the computer Colab give to you. Now you run this block. Here, the Google Drive asks you to give the authorization to connect to the Google Drive. You need to confirm it and use your Google Drive account, give your authentication. Now it is connecting to your Google Drive. so that you can get the dataset and the code here you have uploaded previously. Now the Colab have already successfully connected to your Google Drive. You can see here, Drive, My Drive, and the CMap code you have just created and uploaded. Now you have the dataset and the code need here. After you have connected to the Google Drive, and then you should just copy the code to the Colab, to the notebook here. It takes some time because the Google Drive system is different with the Colab system. It may take 5 minutes or 10 minutes, depending on Google servers. After the block is finished, you can find the code is available on your Colab system now. Dataset here, and your fluorescence image is here. Yes, and then let's run the pre-processing step. First, we need to load the CD file. CD file is generated by the steric night and AC trick. Very fast, 7 seconds, and let's compose the 2D slide into 3D volume as an II.gz file. You should modify your parameters here if you are using your own image. The number slide means how many slides in your Z axis when you're taking your fluorescence image slide by slide. Here embryo names, you should change this slide. You should change this string slide string list to your embryo name list, and the max times, which time point you have capturing your membrane, and which time point you chasing your nucleus, and as well as the XY resolution, Z resolution, and what size output do you want, X, Y, Z. Here, the 256 is corresponding to the 512 in the raw image. 356 is responding to the Y 712, and 214 is corresponding to the Z the number 92. Now the raw folder is where is the data you want to run. You have just upload it by yourself, or you copied it from our example data, and as well as the name dictionary we provided to you. It will update. It will be updated automatically, so don't worry about that. Now you click this block, and next one, and next one. During you running this block, you can find that it is a new folder under the environment raw membrane. The raw membrane is the 3D volume .gz file we need in the training and running. Yeah, and if you get this and within your max time point, now you have successfully composed the raw membrane into 3D. And let's compose the NITF first file into a pico file. Just a little process chip for faster speed. Now we have already finished the 3D computation. We have finished the pre-process step. And on a Colab, due to the lack of GPU computational resource, I do not show the training step here. If you do really have your own labeled 3D data, please train the method on your own computer with at least 2080 time GPU, at least 12 gig. If you just want to run the segmentation, you don't need to train it. You just need to use the model we give to you. And yeah, so let's go to the running step. So, run the segmentation on your own time-lapse 3D embryo. By the way, if you have many embryo and more than 100 time point, you may need to buy a bigger Colab space disk and the system RAM. So let's click this block here. Set up the GPU environment. Install the OpenStreet module. Take 32 seconds and go to the next. Run a prediction using the deep learning network. method will go through the raw membrane and predict the cell membrane for each pixel. You can see that the used system memory has go up to 7 gig and the GPU RAM has go up to 8 gig. It is running the network to predict the cell memory. You can find it after you run this block. Here is the segmented cell membrane 3D file. If you want to see what is it, you can write comment here, and you just Google it how to move a file into another folder. Move to the folder here. Move to your Google Drive folder, and then you can download it on your Google Drive. And this file could be opened by ITK Snap. Okay, after we predict the cell membrane, let's go to the next step. In this step, we are generating cell instant depending on the cell membrane we get just now. So let's run this block. The folder, the seg membrane is just the segmentation of each pixel to predict it is a foreground or a background. In this step, we are generating the instant segmentation for each cell using the CD file generated by Starry9. It takes 24 minutes to run this block from cell membrane to cell objects using two processes. And after we get the cell object, and we should apply the program to detect the dividing cells. Because when a cell is dividing, there are two nucleus, but it should be only one cell object there, so we need to combine these two nucleus as well as these two segmented cell objects into one. So let's run this block. We have already get the segmented cell in this folder for each embryo. If you want to open this nii.gz file with ITK, you should move it. You should, for example, move dataset and run 2001113 PLC 1P2 seg cell 20113 PLC 1P2 001 seg cell .gz to your Google Drive. Where's your Google Drive? Your Google Drive is here. My drive. Here. For example, to here. copy pad. And run it. Wait a minute. You can move it, copy the folder to your Google Drive. Run it. Then copy here and refresh that folder. Check out. Hit here, and then check your Google Drive. Now you can download it on your computer. After you download it, you can open it to have a look what is it with ITK. Yeah, you can see it. There's two sub-objects here. Let's go back to the Colab. And now we have already segment all the embryo in or within the max time you give. Now it's time to run the morphological cell shape analysis. It means we need to calculate the cell volume, cell surface, and the cell content to further biological and physical analysis. Let's run the 4 part. Import the module and go to the next. This is the folder we save the middle output. We create here. Let's go to the next part. Due to the system memory, we only create 2 process here. Just click the run the cell. And some cells take some time. You see here it takes 6 minutes or 30 minutes. So when you are running that, please be patient. Let's wait it until it finished. Remember to change the max times list and the embryo name list if you are running on your own data. Now we get the statistic file for all the segmented cell, and let's go to next. Let's generate the nucleus location file, which could be saved here. And you can check, and go to next. Yeah, we have already get the nucleus location file as well as the statistic file, contact surface volume. Now let's compose them together into GUI data format so that we can open it with the developer software ITK CVE snap. Click this block and the next. Remember to change the time to the correct max number, max times. Click and generate the cell-wise GUI data. It's finished. And say other lifespan. It is finished. Let's check it out. So we save the GUI data directly on your Google Drive folder. So you could check it directly on your Google Drive. Now you can see it here, GUI data-wise. Yes, and then download it. When it's downloading, let's generate the tissue-wise GUI data as well. And then we text the cell-wise and tissue-wise GUI data. Click this. The same as the cell-wise GUI data generation step. One by one. Click it. Remember the tissue-wise as well as the fate, also called the fate-wise GUI data, is generated from the cell-wise data. So generate the fate, the tissue-wise GUI data after you have already generated the cell-wise GUI data. And go to the next step. Yes, now you have already get the cell-wise GUI data as well as the tissue-wise GUI data. And download the tissue-wise GUI data. We have already downloaded GUI cell-wise data just now. Let's extract it. After we extract it, we open the ITK CVE snap. Go to the ITK CVE snap, click the ITK snap, and you can have these windows and click the configure NIFTIF directory and select the path you just download. Go to the path, go to your path, and have a look which one is this. Yes, this one, GUI data cell-wise. make sure the subfolder is the embryo and you click this one, choose. Now you get the UI data and you can check free very simple and directly to view the morphological structure as well as the cell volume, cell surface, and cell content. At last, let's have a look on the tissue-wise GUI data. This one, the same process. Open the ITK snap and configure. Remember, this ITK snap is developed and modified by us. Please download the ITK CVE snap we provide. Go to the path, tissue-wise, the same as the cell-wise GUI data. The subfolder is the embryo name, and you need to open this folder. Choose, and you can see that now the cell is labeled by their fate. Yes, and that's it.